Let's get it started in here.
All right, let's get it started up in here. Hopefully, like that Twilight little, I don't know, picture from the beginning there. We'll talk about more about that in a little bit. Actually, we're going to get to it right now. So the reason we kind of brought that up there was because of Fang and Vang, right? Vampires, fangs, and maybe even werewolves got some fangs and stuff like that. We're going to use Vang. This whole year, we're going to get started up in pre-calc with Vang, verbally, algebraically, numerically, and graphically. These are the 4 representations that we're going to use this year and multiple times, and we have to be able to go in between different sets of them. So we could give you something numerically, and you'll have to be able to verbally verbalize that, or algebraic to graphically, stuff that way. So hopefully you're a Twilight fan. If you're not a Twilight fan, I'm sorry, but I think I'm more Team Jacob. I don't know. I haven't watched the series in a while. Maybe I'm switching to Team Edward. Maybe I don't really care. I don't even know what I'm doing. But we're in pre-calc now, so let's go. It is like kind of Algebra 2. I don't know, beefed up a little bit. So hopefully kind of ring a bell from Algebra 2. Let's get it going. So verbally, Bob has 3 cakes and bakes 4 cakes every 2 hours. So what that means is I want to go from here, I want to go to algebraically. Algebraically is usually an equation, okay? And in this case, I want to write an equation, y equals, well, he starts with 3 cakes, so 3, plus he has 4 cakes every 2 hours, all right? And x is the amount of hours. So if I want to simplify this, I get 3 plus, this is 2, so he bakes 2 cakes every hour. That's what this means, 2 every hour. All right, so there we go. There's our equation, algebraically represented there. Numerically, when I have numerically, it usually refers to a table, okay, a table of values. And in this table, usually we have x and y, which we have obviously up here. But now, what does x stand for? X stands for hours. So in this case, it stands for time, right? X stands for time. More than likely, it always stands for time. There's a couple instances where it doesn't, but more than likely, it always does. Y, in this case, stands for the total cakes. So this is just some number. Okay, total cakes is just some number. So now what I'm going to do is take these 5 values, plug them into X, find out what I get. So if I started at 0, that means he's got 3 cakes already made from like yesterday or whatever. If I use 1 hour, 2 hours, 3 hours, and 4 hours, you can do the math. 1 plug into 2, add 3, that's 5, and then 7, and then 9, and then 11. So there's our numerical representation. Now I want to graph this. I could either graph it from an equation, or I could graph it from a table. Okay, so either or. In this case, the graph from the equation, I go up 3, 1, 2, 3 here. And then the slope is 2, so I go up 2 over 1, up 2 over 1, and then I have my line that way right there, and there's your graphical representation. Okay, all 4 of these are going to be important. You got to be able to go between each of them. Okay, so let's get to the next one. Alrighty, in this case, we are only given the algebraic representation, and then now we got to go find the other 3. What? Hopefully you remember that this is from Algebra 2. This is called function notation. We're going to talk more about that in the next couple problems as well. Function notation. This is read, remember, A of R. Okay, A of R is equal to pi r squared. Now, if you recall pi r squared, remember this is the area of a circle. Area of a circle. Okay, so now I want to write it verbally. All right, so the area of a circle, is a function of pi and its radius squared. So there we go. There's a verbal. Now this is kind of very crazy written. This is very proper. You don't write it this way exactly. That's not that big of a deal, but as long as it's something similar and close to what it means, okay? So now let's go into the numerical. All right, so remember again, in this case, all right, yes, we have r and r, but what if I were to say this? What if I were to say y is equal to pi x squared? Well, it's the same thing. All right, in this case, it's just written differently, different variables, but it really means the same thing. But in this case, I'm going to say this is r, and this is a, and this is area. And what is area usually in? I'm going to say we're usually measuring the radius in inches. So I'm going to say this is inches squared, because that's the units there in area. And the radius, hey, I'm going to say this is just in inches. All right, that's just in inches there. Okay, so if I plug in -2 to r, I get 4. 4 times pi, I'm just going to leave it as 4 pi. If I plug in -1 to r, I get just pi. That's pretty easy. If I plug in 0, I just get 0. If I plug in 1, I get pi. And if I plug in 2, I get 4 pi. Leave it as pi. Don't put it as 3.14. Just leave it as pi for right now. It's not that big of a deal right now. Well, now I want to graph this. Again, you could graph this if you want, or you could graph it numerically. In this case, I'm going to graph it numerically because the numbers look a little better than that equation. So if I plug in -2, well, actually, let's start here, 0, 0. That's pretty easy, so let's go 0, 0. Hopefully you see that these are the same and those are the same, so that if I do 1, I can just reflect it over. We'll talk about what the graph looks like here in a little bit. If I plug in 1, I get pi, so 1, and pi is 3.14, so it's 1, 2, 3, kind of up here somewhere, okay? And now if I reflect it over, I get somewhere around there. If I plug in 2, I get 4 pi, but 4 pi is right around 12.56, give or take. So I'm going to go over 2 and up 12.56. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, give or take right there. Let's reflect that over. We get that. As you can see, the graph kind of comes down and then goes back up. I know my graph is terrible, but it's kind of hard with this pen that I'm using here. So this is called, remember, it's called a parabola. Okay, it's a U-shaped graph. So it could be U-shaped that way or U-shaped that way. The reason it is this is because this is positive. The coefficient is positive. Okay, so again, got to make sure we can go in between all of these different relationships here. So this is function notation. Pretty easy. Hopefully you remember from Algebra 2. If not, we're going to get a crash course in it right here. So f of -3, remember f of -3. Instead of saying f of x, this x is -3. So what we're going to do is we're going to take this function, wherever there's an x in it, we're going to plug in -3. So it's 9 minus 4 times -3. 9 plus 12, which is 21. So we write this and say f of -3 is equal to 21. There's our answer for that one. Second one, this is not saying x is equal to something. We know this is the value. So f of x is equal to 10. So instead of us plugging it into x, we're going to plug it into f of x. So we're saying 10 is equal to 9 minus 4x. Subtract, bring that over. I get 1 is equal to -4x. X is equal to -1/4. So what that means is that f of -1/4 is equal to 10. Okay, that's what that tells me. If I plug in -1/4 to x, I'll get 10. The third one there is h. Well, instead of this being a number, it really is a number, it's a variable. I'm just going to plug that into where the variable is. So it's 9 minus 4 times h, or just 9 minus 4h. So that's what f of h is. Because f of h isn't an actual number, well, you don't know the value of it, it just has to stay that way. This x plus 2 now is going to get plugged in wherever x is. So it's 9 minus 4 times x plus 2. And then I have to distribute, so I get 9 minus 4x minus 8. So my answer is -4x plus 1, x has come first, is equal to f of x plus 2. That's a terrible 2. And that is my answer there. Okay, that's function notation. Please make sure you understand what you're supposed to be doing. All right, next problem here, guys. We got Mr. Bean. If you guys don't know who Mr. Bean is, he is like an English actor. I'll put some videos here in a little bit. And now. Well, he is entering a 7-day Pokemon competition. Apparently, he's very big on Pokemon. The function below represents the amount of cards he has over the course of the tournament. Right there is your function, right there. And we got to answer all these questions. We got four questions, but some have different meanings and different amounts there. So how do we do this? Well, what we could do, which is what we've been doing this whole section so far, is I could technically plug that into T because that's what it means, right? Into all of them. And I can find out what that means. I can solve it, all right? But I'm going to show you a different way using a calculator. We're going to use the TI 84 graphing calculator on this problem. If you do not have access to one, you can, I don't know, by all means, do it the long way. If you need to borrow one, I guess find one, but for the most part, I'm going to show you how to use a graphing calculator on this problem. So let me pull up my handy dandy calculator right there. All right, what I am going to do is I'm going to show you kind of where you need to go so that you can get this thing correct here, okay? So first, what you need to do is you need to go to the y equals. It is right here, right there. All right, make sure everything cleared everything out, and you're going to type that in. You're going to put parentheses around the fraction, so 1 divided by 3 in parentheses, 1 divided by 3, close parentheses, and then t to the third. But I'm graphing with x's and y's, so I'm going to change all of these variables that are non-x's to x's. X is going to be right here where it says x, t, theta, and n, underneath the mode button. X right there, raised to the third power. Remember, caret is that, raised to the third. Minus 2t squared, so minus 2x squared, and there's a little icon for the squared, minus 2t, minus 2t, and then plus 50. Boom goes the dynamite. If you don't use parentheses around the 1/3, it might or might not throw you off, but over the course of time, without using parentheses, it will throw you off, so get used to using them, please. What I'm going to do is then hit enter, so it's into the calculator, and then I'm going to go to my graph, and let's just see what happens here. Oh, my graph doesn't look very good, does it? It looks like almost like a straight line up and down. Well, that's not going to mean anything. So what I'm going to do is I'm going to go to my window, okay? My window, let me do something real quick here. Okay, so I just changed my window. I'm going to show you what I did here. I changed my window to -10, 10, 1, -10, 10, 1, 1. The x min, okay, this is the smallest amount on the x-axis, all right? X max is the biggest amount on the x-axis. X scale is how you're counting from min to max. So for instance, if the x min was 1,000 and x max was 1,000,000, do you want to count by ones from 1,000 to 1,000,000? No, you're going to, change that count number, okay? Y min is the smallest on the y. Y max is the biggest on the y. Y scale, again, is the counting of the y's between the min and max. And then x res, always keep that at 1. I don't even know what it does, but don't mess around with it. Keep it at 1, please. Okay, so if I keep this at -10, 10, 1, this is what we call the standard window. Standard window. Anytime you want to come back to the standard window, you can hit this zoom icon, and you can hit 6, which is Z standard. So that's the standard window. If you do that, this is what it will appear. Look, again, it looks like a line, but that's not really what it's going to be, okay? So let's come back to the original problem here. What does T stand for in this problem? What does T stand for? T stands for what? The total time, right? T is equal to the time in hours, okay? Well, actually, it could be days as well. Well, we'll say days in this case, because we have days right here, okay? So we'll use days in this case. So it's a 7-day tournament. So now what I'm going to do is I'm going to go to my window, my X-min. Well, what's the smallest amount of days you can have? Well, that's 0. What's the biggest amount of days you can have? In this case, you'd have 7. Now, you could make it 8 or 9 or 10. That's fine. I'm going to put it at 7. Anything a little bit bigger than the max is fine. You don't have to do it 100, but do it at least to the maximum amount, which would be 7. X scale is 1. Not going to change that. Y min. Now, what does the Y stand for? Or what does the C of T stand for? So the total number of cards, well, can he have less than 0? No. So I'm going to change that number to 0. Y max, that's how many he has. So how many can he have? Well, it says 50 here, and I don't know what's going to happen over here. So I'm going to say 100, just because what if he goes up, right? What if he goes above 50? Then we have to account for that. So let's do that. And then I'm going to count by tens, because I can. All right, I'm going to hit enter, and then I'm going to go graph it. And let's see what happens. Oh, this is cool. So you see that it starts at 0, so he has this many cards. It goes down for however many days, and then it hits some value here, and then it goes back up. So at the end of the 7th day, he actually is increasing cards, and maybe they keep going. I don't know, but for right now, this is all we need. All right. So what do I got to do? I got to find C of 3. So remember, I said you could just plug it in. But that takes too long in terms of doing all that. Okay, so how do I do that on a calculator, which makes it easier? What I'm going to do is I'm going to hit trace. Okay, I'm going to hit the trace button. Well, I'm going to trace when x is 3. Okay, so I'm going to hit the number 3 and then hit enter. Boom. So when x is 3, he has 35 cards. So C of 3 is equal to 35. What does it mean? This is how many cards he has after 3 days. I found it, 35. What does it mean? That's how many cards he has after 3 days. That's exactly what it means. Okay? Let's go to the second question. What does C of T equal 40 mean? Estimate it. Well, it says estimate. It's not going to find exact. We're going to use some different strategies here to find the estimation. So what I'm going to do is I want the Y value to be 40. Okay, so I'm gonna hit trace where it is. It's already at there, and I'm going to try to get as close to 40 as possible in this column here. So I'm going to keep going. Where do I get 40? Oh, looks like it's going down, right? So I got to go back up this way. Where do I get it? Where do I go? Oh, right there. So about 2.085. About 2.085. We'll go 3 places. Okay, 3 places. But you see that it's going down, and then it comes back up. So it looks like it might cross somewhere in there as well. So I'm going to find that dot, because this looks like it's a parabola or some sort of quadratic function. It's got to also hits another spot. So what I'm going to do is I'm going to scroll over, keep going, keep going, keep going, and I'm going to find out where it hits 40 there as well. So where does it hit 40? This is probably a little closer, so 6.18. Okay, so what does this mean? So I just estimated it, 2.085 and 6.18 days. What does it mean? This means that after this amount of days, that's how many cards he has left, which is 40 cards in this case. Okay, so there you go there. What does the y-intercept mean? The y-intercept is right here. What does it mean? That's his starting value, or the starting amount of cards. And think about it. What does the y-intercept, what's the x value of that y-intercept? Well, it's always 0, right? So the x is always 0. So if that means that's 0, that means that's going to cancel, cancel, cancel. So that means this value is always going to be the y-intercept. No matter what, always going to be the y-intercept. All right? What is the lowest amount of cards that Mr. Bean had? Okay, what is the lowest amount? Well, I'm going to go back to trace, and my lowest amount would be somewhere in this area here. So I'm going to trace, see if I can find what I can do. So 31.124, oh, it goes down, 0.89, oh, it keeps going, 0.86, 0.87, oh, it looks like right here, 4.393 days and 30.8726. So 30.8726 cards. Now again, you can't have a part of a card, but this is estimation because we don't know the exact way how to do this yet. We will find that out in subsequent lessons. Okay, so please make sure you have all these buttons, make sure you're hitting them correctly, and then we'll get all that information later. All right, well, so right here we did talk about a little bit of Zoom Standard. We didn't talk about Zoom Fit. And so I want to talk about Zoom Fit. So if I pull up my calculator again, I have the same function in my y equals. All right, I'm going to go to my Zoom button, which is right there, and I'm going to go up, and it'll say Zoom Fit, which is 0. Okay, I'm going to hit 0. If I hit 0, you see it kind of makes my graph look pretty nice. All right. But what it doesn't tell me is my window changes. So my window, my x's didn't really change, but my y's did. Instead of starting at 0 for my y min, it starts at 30 and then goes to 52. Okay, so you can see there's a big difference there. Zoom Fit. Okay, so let me back up a little bit. Let me go back to the window right here. These numbers aren't terribly bad. Remember I'm going to put the numbers that we had. We had 0, 7, 1, we had 0, 100, and then 10. These numbers were ones that we used from the equation, but what happens if you're having a hard time figuring out the numbers to use? Then you can use Zoom Fit to get a framework. Meaning that once you use Zoom Fit, you're going to have to go to your window and then kind of mess with it a little bit more, but at least you can see the graph. So if you ever put a graph in here and you hit enter and you graph it and there's nothing there and you're not sure what points you should be using, use Zoom Fit and then it'll show you the graph and then just change the numbers to where you want them, okay, what you're looking for. All right, so this isn't a be-all, end-all, but at least gets you to see the graph. This is probably the most important thing right here, okay? The next thing that I want to talk about is the table set window. So right where it says window, right above that in blue, it says TBL-SET, okay? So if I hit second, because it's in blue, and I hit TBL-SET table set, this is what it pops up as. So the table start, this is now referring to the table. Well, let me back up then even further. How do I get to the table? You see above the graph button, it says table in blue, so I'm going to go there. Okay, here's my table. So all my x's are labeled 3, 4, 5, 6, 7, 8, 9, and I can keep on scrolling for days, okay, to get the next, whatever the y value is. So if I plugged 17 in, I would get this many cards. If I plugged 20 in, I would get this many cards. Well, what happens if I wanted to find 1,000? After the 1,000th day, so after the 1,000th day, how many cards did he have? Okay, let's find that out. Well, if you didn't know about this menu to TBLSET, then you would have to do this for up until 1,000, okay? Or just plug 1,000 in. But here's how you can do it faster. Hit second, TBLSET. I want a table start at 1,000 because that's what I want to know. All right. And then I could hit enter, and then I can go back to my table, and I can find out the value, and I can scroll over, and it'll tell me right there. Okay. But there's something also pretty cool about this, is that this triangle table is delta. Delta stands for the change. So on my table, you notice I was going up by ones. Well, I could go up by 50. Or I could change that to 20, or I could change that to 0.05 if I wanted to go up by that. And then I'll show you what happens with my table here. So 1,000 now goes up 0.05, right? And it keeps going up 0.05, 0.05, 0.05. So you can keep doing that. Your table can change based on what you want it to be. Another cool thing about this table setup is if I go down to the independent line there, this auto means it's going to automatically do what it's been doing, right? If I go to ask and hit enter and then go back to my table, you can type in whatever X's you want. So if I wanted to type in 1,000, boom, and then I scroll over and then there's my X value. If you wanted to, you can type in 20. Okay, you can type in 0.2. You can type in negative numbers, -6. It'll give you all of that information. So instead of having to find it in the table, you can just type it in by going to this TBLSET menu. Please make sure once you mess with this, change it back to its original, because the next time you graph, this is what it's going to stay as. So table start, usually we keep it at a 0. The delta table, we keep it as a 1. The independent, we keep it as auto. And we always keep the dependent on auto. Always, always, always. Okay? And there we go. Now if I go back to my table, and now I go back and I have my nice round numbers again. Okay, let's go to the next problem here. All right, this is the last problem in this section. What I want you guys to do is take a minute to try this using a graphing calculator. Do what we did in the previous one. Hit pause and then hit play. Hi, it's me, LeBron James. LeBron James! Pause video. Okay, so on the right here is the information that you have. Let me close on my calculator. So this is the graph of what it looks like. This is the window. This was a 0. For some reason, it didn't come through. So 0, 24, 2, 0, 300, 500, 1. Where did I get the 24 from? It's 1 day in Vegas is what he spent, which is 24 hours, because it says hours right there in the problem. I want to count by 2s. I started at 0 for the min because you can't have any more than $0. Max would be 300. I just did 300 because he has 180. So when you're trying to win money gambling, like you hopefully want to go up. So I just put it at 300. If the graph crossed more than 300, then I would have had to change it. But it didn't. So I was in luck. I can only count by 50s. So what does B of 12 mean? B of 12 means negative 6.72. You could have found that out by typing in, right, doing the trace and typing it in. And it was negative, which means he lost all his money already. So he has $0 left after 12 hours in Vegas. What does B of T equals 80 mean? That means that somewhere, I think it was, let's see, it was 50, 100, somewhere in this area here is when he had $80, and that's right around 11 hours. It wasn't exactly 11, but it was approximated as 11, so that's kind of what I used there. What does the y-intercept mean? The y-intercept right there is how much he started with, and that was $180, because remember, this is what he started with, so that's always the last value. What does the x-intercept mean? The x-intercept is right there, and that just means that when he has 0 money left. So it's right around 12 hours, a little bit less than that, but pretty close to that, is when he has $0 left. When does he have the most money? He has the most money up here, and you could trace that. It's estimated at $268.22. I just put 0.228. That's fine. If you wanted to put 0.23, that would be acceptable. But there you go. That is this lesson. So have fun. Ask questions. I'll see you later. Deuces.